So we saw that event-driven programming is the way to go if we want to design graphical user interfaces. So let's look at event-driven programming in Java. So event-driven programming in Java is implemented using something called Swing. So this is a toolkit, as it's called, right? So you can think of it just as a library or a package. So it is a package of objects and various other functionalities which allow us to do this kind of graphical user interface programming using events and listeners. So Swing is actually built on top of a more abstract event handling framework called AWT, which stands for Abstract Windowing Toolkit. So AWT is a low-level thing which manages events and interfaces, and you can also use it to design customized events, which we will not discuss in this part of the course. But Swing is built on top of that, and Swing has specific types of events which are associated with specific listeners, as we will see. So the most important feature about this in Java is that this relationship between components which generate events and listeners is very flexible. We talked about the timer and said that in our example that we did with callbacks, we said that the object that created the timer in our example was the one that was notified when the timer elapsed. But we could have a more general thing which says that the object that creates a timer passes a reference to another object to be notified when the timer elapses. And similar things happen in graphical user interfaces. So we could have a common listener listening to multiple objects. So for instance, if we have 3 different windows, buttons on a window, we might want to do something to the underlying window depending on the button. So the same listener must listen to all 3 buttons so that there is no confusion about what should be done when different buttons are pressed. On the other hand, we could have one button talking to multiple listeners. So for instance, if we have some kind of a global quit or a logout or a restart, right? So this must close every window which is available on the system. Or if we just want to quit an application which has opened multiple windows, we want to close all the windows. So we don't want to go around individually clicking them. So if we click this one button, then all of those windows need to be notified. So in the first example, we had one window listening to multiple buttons. Here you have multiple windows listening to one button. So we can have many event generators talking to one listener, and you can have one event generator talking to multiple listeners. So this means that we need to, in Java, explicitly set up this connection. It's not that every time we create an object, right, which has some capability of generating events like a window or a button, automatically a listener is created. We have to separately create the appropriate listener for our requirement and set up this correlation, as we said, that add to a given object which generates events, we have to tell it which listener is the one that will be notified. So this manual thing is required, and therefore a side effect of that in Java is that if you do not do that, the object that is generating events will just keep on generating them and nobody is listening. So sometimes we have, when our application is not working properly, we click on something and nothing happens. We want to close the application is unresponsive. So one of the reasons an application could be unresponsive is that the thread which is supposed to be listening to that event has unexpectedly quit, right? So there is nobody listening. So all your clicks have no effect because there is nobody on the other side receiving those signals. So let's start looking concretely at some examples of how Swing does this. Right? So buttons, as we said, are simple objects which you can press. So in Swing, there is a built-in class called J button. So in general, these Swing objects have this capital J at the beginning, and without the J, these correspond to things which are defined in the underlying AWT class, which we will not normally deal with. So whenever you see a Swing component, you expect to see a capital J in front of it. So J button is a built-in class. It's a button, right? So we don't have to define anything more about it because it's given to us as a predefined class. And a J button, as defined, talks to something called an action listener. So remember that we said that a timer, right, talks to something called a timer owner. This is a predefined connection saying which interface is the one that is notified when a timer that elapses. So when a button is pressed, the kind of interface that I need, the kind of implementation that I need to talk to is something that looks like an action listener. Now in a button, there's not much you can do, as we discussed. You can just press it, right? So therefore, the action listener essentially has a unique function that is called when the action happens, and that is called action performed. So in other words, when you press a button, so you get a button, right, and you press it, then what happens is that there is a corresponding action listener, and in that action listener you perform the implementation of action performed. So this whole thing happens automatically, right? So the runtime system makes sure that when this happens, this happens. So you don't have to make this connection after you set it up initially. Initially you say this button talks to this action listener, that's all you have to say, and you of course have to provide the code on both sides. You have to say what the button looks like and what the action listener is going to do when it gets the signal. So what the button push generates is an object of type action event. So the events themselves, like everything else in Java, have structure because we might want to know, as we will see later, something about the event. So this generates an object called an action event, which is then analyzed by this action performed. Right? So here is a kind of simple way to do this. So you first set up a button, right? So you say that I have a J button, which I will call B, and I will now create a action listener. Sorry, this is a constructor which says that when I create a J button, right, in this class, I will pass to it an action listener, right? And what this will do is it will set up the new button and it will add the action listener that is passed to that button, saying this button is now connected to this particular action listener. Right? So when I create a button, this is what I need to do. I need to set up something. So here, for instance, this is a property of the button. What will the button display? Right? So it displays the word my button. And what will the button talk to when it is pressed? That's given by this add action listener. Now on the other side, I must create this action listener, right? So I will create a class which has an implementation of this function action performed, because that's what the action listener interface asks for. So I will create a separate class which does this. So now in practice, what I will do is I will first create a new object which can listen. I will then create a new button, and to this button I will pass the object that can listen, so that that button B, or this button M is now connected to this listener L, right? So this is an abstract example. We will look at a little more concrete example in a minute. So this just sets up a button. Now unfortunately, if you just set up a button, right, it's not displayed. So displaying a button is a different thing altogether. So Java has a notion called a frame, and a frame is what can be displayed. So we ultimately have to create a frame and make it visible. Otherwise, these things are just happening in the background. So although there is a button that the user can press, the user cannot see that button and therefore cannot interact with it. So what we have to do is actually a two-step process. So we have to take the button and we have to put it somewhere, right? So there will be a button. So it will set somewhere, and that somewhere is what Java calls a panel, right? And then this panel, right, will have to go into something bigger, which Java calls a frame, and this can be displayed. So when I display the frame, it will display this panel. This panel boundary is typically an abstract boundary. I mean, it need not have a boundary that's visible, but in that there will be a visible button which the user can interact with. So now if I come to this button and I press on it, then automatically the appropriate listener will be invoked. But if I cannot see this button, I cannot press it. So that's why we have to go through this extra level of setting up this display. So we have to put this in a panel. So not surprisingly, given what we talked about with button, a panel in Swing is called a J panel, because everything in Swing normally starts with a capital J. So we first import some useful packages that we need for Swing. So remember, it has this underlying AWT, and this is the Swing thing. So what we need to do is create this button panel. So this button panel will be a subclass of JPanel, and this panel will, so remember where the panel is. So we have this panel, right, and we have a button B inside. So this button has to talk to somebody. So what we are going to do is make it talk to the enclosing panel. So the panel will not only contain the button, right, but the panel will also implement the function that responds to the button. So the first thing is to create a button, right. So here is, I declare a variable of type J button, and now I create in this button panel, when I create a panel, I create a new button. In this case, I am going to give it a label red. Then I am going to add this current panel as an action listener. I have not yet told you how this action listener is going to respond. That's going to be here. So this is going to be the implementation of this action listener part, right? So that's yet to come. But this class already knows how to respond to action listener events, right? So we say that I have a red button which has a label red. It's going to talk to the enclosing panel, that is this object, and then having set up this button, I add that button to this panel, right? So this just creates a button and puts it physically in this panel. So I have now embedded this button in this panel. So I still have to talk about what this action listener does, right? So the listener in this case is going to color the panel according to the color which I put on the label red, right? So what the action performed in this case is it sets the background color to a built-in color which Swing has called red, okay, and then it repaints the panel. So it makes the panel background red, right? So the effect of clicking this button is to take the panel that is there and make it red. Earlier it was probably not red, and now it is red. Okay, so that's the effect that you're going to see. Now remember that the panel itself needs to be sitting in a frame, because the frame is what Java can display. So we need to create something which is of type J frame, right? So remember, J button, J panel, now J frame, right? So the button is embedded in the panel and the panel is embedded in the frame, and the frame is what Java can actually display. So we will have now a constructor, but now it turns out that the frame itself, what I display, generates its own events. Why? Because this is what we see when we open a window, right? That's the one which has the terminate, full screen, and minimize and so on. So every frame comes with its own events independent of the events that are generated by the objects that are embedded in it. So in order to implement a button frame, I need to connect it, to implement a J frame, I need to connect it to a listener. So like in the panel, we are going to make this frame talk to itself, okay. So the corresponding class for a frame is a window listener as opposed to the action listener that we had for a button. So it turns out that frames can generate 7 different kinds of methods, 7 different kinds of events. But fortunately, we are not obliged to actually implement all of them except the one which corresponds to closing, right? So the only thing that we must have an implementation for is the function that is to be called when you press the button which asks you to quit the application, right? So this is the function that we end up calling when you quit the application, the one when you press X, right, is called window closing. So we have to provide an implementation for window closing, and so here is a suitable thing which just says exit this program. Okay. Now there are all these other things like activating, closing, deactivating, de-iconify, iconify, and all that. So you can provide suitable implementations as to what to do with that visible frame when all of these things are invoked, but it is allowed to just make them do nothing, right? So this is like having an unresponsive button. You press it, nothing happens. You want to make this thing full screen, nothing happens. You want to iconify it, nothing happens. You press X, it dies, right? That's the only thing that we're obliged to do. So the other 6 types of events can be ignored. So what we have done is we have created a frame in which we are going to put the panel. We have not yet done that, but first thing we have to do is that frame itself has to have a corresponding listener. So we are making this frame talk to itself. The frame implements its own listener, just like the panel implements a listener for the button that it encloses. Now there is one more minor complication. So a frame is not just a kind of single level object, it's a multi-layered object. So it has, so a frame abstractly has multiple layers associated with it so that you can separate out different parts of it. So what we are interested in is the layer on which we put the things that are visible, and that's called the content pane. So a complex J frame has one part called the content pane, which is where the visible objects that we add to the frame are to be defined, right? So at the bottom here we have suppressed now the code for those 7 listener interface functions, right? And instead we are focusing on now what the frame contains. So first of all, we have to extract its content pane, right? And now we say that when we create a frame, we set its title and its size. So it's going to have a thing saying button test, and it's going to have a 300 by 200 size in terms of the geometry of the window, 300 pixels by 200 pixels. We are going to say that this button frame talks to itself, right? It has its own implementation for all the events that it generates. And now finally I add that panel which I created, right? So I get this content pane and I add a new button panel to it, right? So a button panel, remember, we just defined, is the one that then in turn creates a button called red, and it implements a function. When red is pressed, turn the panel background to red. So that's it, right? So this is finally we have got this. Then of course we have to write a main program which creates the frame and makes it visible. So what we have done is we have set up this frame which contains a panel which contains a button. Now we have to create a frame and make it visible. So essentially we have to do this. We have to create a new button frame and set visible to true. That's the way that we make it visible on the screen. Otherwise, by default, when you create a frame, it's not displayed, right? Now one small thing that happens here is that we have to hide this whole code inside this function called invoke later, and this is a technicality which is basically to do with the fact that everything in this is running in a threaded mode. Remember that we said that the graphical user interface is kind of interacting with the user separately from what's happening in the rest of the thing. So you have to be responsive to clicks and all that while you're doing whatever you're supposed to be doing. So in order to make these things work properly, we have to put all the Swing components which interact with the user into a separate thread, and that's what this. So you just have to remember to do this. You don't have to change it ever. Wherever you want to create some frame, you have to put it into this event queue.invoke later, and this is a format which uses the lambda expression. There is also an explicit way of doing it. You can look it up. So what this does is it puts this frame into something called an event dispatch thread, and this ensures that the processing of the interactions, you know, the button presses and all these interactions that the interface generates do not contradict what is happening. So you don't get blocked, right? So the computation does not get sort of held up because, or the interface does not get held up because the computation is doing something heavy, right? If they were running in the same thread, then you have a problem that you have to manually manage the listening to. So for example, you're downloading a large file in a browser and there is a stop button. So if you are going to interleave how much you download before you check for the stop button, then you are controlling the rate at which the stop is responded to. Whereas if the stop is parallel to the download, which is what is going to happen here, because the stop will be part of the GUI and the download will be in a different thread, then the stop will be more responsive because it is not really directly connected to how long or how heavy the download process is. So anyway, you set this all up and this is what you get. So when you first run this code, so you have this main function which calls a JFrame, which calls a JPanel, which includes a J button in it. You see this kind of a window. So remember that we created the frame with this title button test, right? It has an X built into it because it always has an X, right? And this is the panel. Okay, so this part is the panel implicitly. Okay, so the panel is embedded in the frame, and inside the panel this is our button. And when we created the button, we put this label red on it. Right? So that's all we see now. We see a button with the label red because we created a button. The panel created a button inside it with the label red, and the frame embedded this panel and put a frame title called button test. So now if I click on this button, what happens is that the panel turns red. Right? So the surrounding area outside the button, which is the background of the panel, turns red. And notice that this header part of the frame is not part of the panel. Right? So this title window is separate. So only the bottom part turns red. Right? So what we have seen is a very simple example of how we program a graphical object in Swing. So we will see that Swing has many different types of objects. So each object will generate its own type of event, and we have to now create the corresponding handler object, the event handler, which will listen to these events and respond to them. And what we finally have to do is put everything in a frame, because Swing will only display frames, right? So we have to put individual objects into panels, and then we have to put these panels into frames. So we have to do a little bit of work to get all these listeners moving and all these things embedded in each other. And finally we can create that even more complicated. In that thread section, we have to create the new frame and then make it visible.